Einstein's equation, E equals mc², is one of the most famous equations in science. Many people have seen it, but fewer people understand what it really means. At its heart, the equation tells us something profound. Mass and energy are deeply connected. Mass is not just stuff. It is a form of stored energy. Even a tiny amount of mass can contain an enormous amount of energy, because it is multiplied by the speed of light squared. In this video, we will explain the meaning of E equals mc² in a simple visual way. We will also see why it matters in nuclear reactions, the sun, particle physics, and modern technology. Here is what this video will explain. First, we will look at the famous equation itself. Then, we will see what E, m, and c² mean. Next, we will explore why mass and energy are not completely separate things. We will also see why the speed of light squared makes the energy so enormous. Finally, we will connect the equation to the sun, nuclear reactions, and modern physics. The main idea is simple: mass contains energy. E equals mc² is probably the most famous equation in physics. It appears in textbooks, posters, science documentaries, and popular culture. But the equation is not just a symbol of genius. It expresses a deep truth about nature. Before Einstein, mass and energy were usually treated as different kinds of things. Mass was associated with matter. Energy was associated with motion, heat, light, or work. Einstein showed that mass and energy are linked. Mass can be understood as a concentrated form of energy. Let us break down the equation. E stands for energy. M stands for mass. C stands for the speed of light in vacuum. The equation says that energy equals mass multiplied by the speed of light squared. The speed of light is already extremely large. When we square it, the number becomes enormous. That is why even a very small amount of mass corresponds to a very large amount of energy. Small mass can mean huge energy. The equation does not mean that mass and energy are the same in every simple everyday sense. Instead, it tells us that mass has an energy equivalent. A body at rest still contains energy because it has mass. This is called rest energy. In ordinary life, this energy is not obvious. A stone on a table does not suddenly release its mass energy. But in nuclear and particle processes, small changes in mass can appear as large amounts of energy. Mass is one way energy can be stored in nature. The power of E equals mc² comes from c². The speed of light is about 300 million meters per second. When this number is squared, it becomes incredibly large. That means 1 kilogram of mass corresponds to an enormous amount of energy. Even 1 gram of mass contains far more energy than we might expect from everyday experience. This is why nuclear reactions can release so much energy from such small amounts of matter. The factor c² turns a tiny mass difference into a huge energy release. In many nuclear reactions, the total mass after the reaction is slightly less than the total mass before the reaction. This missing mass has not vanished into nothing. It has been converted into energy. The mass difference may be very small. But because it is multiplied by c², the released energy can be very large. This is why nuclear processes are much more energy-dense than ordinary chemical reactions. Chemical reactions rearrange electrons and bonds. Nuclear reactions involve changes inside atomic nuclei. A tiny loss of mass can become a powerful release of energy. E equals mc² appears in many areas of real physics. It helps explain nuclear fission, where heavy atomic nuclei split into smaller nuclei and release energy. It also helps explain nuclear fusion, where light nuclei combine to form heavier nuclei. It appears in particle physics, where energy can produce new particles with mass. It also appears in high-energy experiments, nuclear medicine, radiation physics, and astrophysics. The equation is not only about bombs or reactors. It is a general relationship between mass and energy in nature. Where mass changes, energy must be accounted for. The Sun is one of the most important examples of mass-energy conversion. Deep inside the Sun, hydrogen nuclei combine through nuclear fusion. The final products have slightly less mass than the starting particles. That small mass difference is released as energy. This energy eventually reaches Earth as sunlight. It warms our planet, drives weather, supports photosynthesis, and makes life possible. So E equals mc² is not just an abstract equation. It helps explain why the sun shines. Sunlight is connected to mass becoming energy. A common misunderstanding is that mass simply disappears in nuclear reactions. That is not the best way to think about it. Mass and energy are part of a larger conservation principle. When mass decreases in one form, energy appears in another form. The total mass energy is still accounted for. In nuclear reactions, the energy may appear as kinetic energy, radiation, or other forms of energy. So the equation does not say that nature allows something to come from nothing. It says that mass and energy can be converted between forms. Mass is not simply lost. It is transformed into energy. Let us now gather the key idea. E equals mc² tells us that mass has an energy equivalent. Mass is not just passive matter. It represents stored energy. Because the speed of light squared is so large, even a tiny amount of mass corresponds to a huge amount of energy. This explains why nuclear reactions can release so much energy. It also helps explain why the sun shines and why particle physics can transform energy into matter. The key takeaway is simple: mass is stored energy. Thank you for learning with Prep for Uni Online. If you want to understand modern physics more deeply, continue with our lessons on special relativity, nuclear physics, particle physics, quantum physics, and astrophysics. Prep for Uni Online provides free university preparation resources for students exploring physics, engineering, science, technology, mathematics, humanities, business, health, and the arts. Our goal is to help students build strong foundations before university study. Visit Prep for Uni Online and continue your learning journey.